everyone, and welcome to Pizza Chemistry class. ChemBridge is the name of my chemistry channel, and in this channel we'll be dissecting chemistry within the secondary school level of education. We'll be taking it topic by topic. As you follow me, be you a student preparing for WAEC, NECO, University Matriculation Examination, or IGCSE examination, O-level, A-level, you are going to get the necessary knowledge of chemistry that will help you as you endeavor in your as you go on in your chemistry endeavor. Today is the first series of this class, and in this today class we'll be starting with atomic structure. I tagged it atomic structure 1. In this lesson we'll be looking at the atom, its composition, and everything that has to do with the atom and its structure. So here are the lesson objectives we'll be looking at. Number 1, by the end of this lesson, students should be able to 1, define an atom, 2, identify its 3 main subatomic particles. In other words, the student should be able to identify the protons, neutrons, and electrons, including their relative charges, masses, and locations within the atom. Students should also, number 2, 3, be able to determine the atomic number, mass number, number of subatomic particles in a neutral atom, as well as in ion. 4th objective, students should be able to solve exam style problems involving atomic structure. This is what we intend to achieve in this particular edition of this class. So let's go ahead. What is an atom? What is an atom? Now, have you ever wondered what matters are made up of? When you listen to the word matter, what is the composition? If you look at a structure, a given crystal structure, have you ever had a thought that there are still some particles that make up such matter? Now, every matter is made up of atom. Now, in chemistry, we have what we call the atomic model, which are the model we use to identify or describe the atom. Now, this is a typical atomic model. Now, this atom should be atom of, let's look at, identify whether we can, from this, identify the type of atom present. I have the opening here, 1, 2, 3. 3 openings. 3 openings. Now, if it has 3 openings, what does it signify? This one has 2 openings, 1, 2. Now, this openings is signifying the valency, the number of electrons that this atom has in the outermost shell, or the valence as the case may be. So, this is another atomic model. I can say that we can describe this to be an atom of calcium because of this valency of 2 opening. I have again an atom of hydrogen. This is a hydrogen atom. It has only 1 bond connected, 1 electron. 1 electron. So, by the way, coming back to our question, what is an atom? Say that an atom is the smallest particle of an element. An atom is the smallest particle of an element that can take part in a chemical reaction while retaining chemical property of that element. The smallest particle of an element that can take part in a chemical reaction but still retains the chemical property of that element is what we call an atom. Just as I say that all matters are made up of atom. All matters are made up of atom. So the smallest part of that matter, that when it is present in a chemical reaction, it shows the chemical property of that matter. It helps us to identify that matter is what we refer to as an atom. Now let's go ahead. All substances are made up of tiny particles of matter called atoms, which are the building block of all matter. So matter, atom is the building block of what? All matter. Atom is the building block of all matter. Each atom is made of subatomic particles. Now, even though that we say that the atom is the smallest particle of an element that can take part in chemical reaction, the atom still have a subatomic particle, smaller particles that are present are contained in atom. An atom has three main particles: the proton, the electron, and the neutron, or protons, electrons, and neutrons. These are subatomic particles, other particles that are still contained in an atom. And we are going to be dissecting how these particles are located in an atom. Now, the protons and neutrons are located at the center of an atom, which is called the nucleus. The proton and neutron are located at the center, called the nucleus. In other words, if an atom is like a circle like this, take this circle as an atom. Inside here is the nucleus, and inside this nucleus contains protons and electrons, and neutrons, I need to say, and neutrons. That is what is present, how the atom is made up of. The center contains protons and neutrons. Protons and neutrons. What about the electron? Where can we find the electron? Now, the electrons move very fast around the nucleus in an orbital part, or what we call shells or energy level. Remember that the electron is not usually stationary. The electron keep on moving. It keep on revolving around in an orbital or in a certain energy level, because there is different energy level in each atomic structure depending on the type of atom and the sub-level that is present in that atom. Also, the mass of the electron is negligible. The mass of the electron is so small that we usually refer to it as a negligible mass, because the mass does not actually contribute to the mass of the atom. An atom is contained within the nucleus. Within the nucleus, where the protons and the neutrons are located. So, atom has three particles: protons, neutrons, and electrons. Now, the proton and neutrons are found in the nucleus, the center. The electron revolve around, move in an orbital part or in energy part or energy level called the shell. So, we move on. Now, let's look at this. This is a typical atomic structure. Now, in this atomic structure, we can see this color, this color, this color, this color, this color, this color, this color is what? The protons. Protons. Now, this color happen to be what? The neutrons. So, in this atom here, in this atomic structure, we have 1, 2, 3, 4, 5, 6 protons 1, 2, 3, 4, 5, 6 neutrons in the nucleus of this atom. Now, if this an atom is a neutral species, the number of protons will be equal to the number of electrons. And let's count the number of electrons. The electron revolve. We have 1 in the first shell, 2 in the first shell, 1, 2, 3, 4. 4 in the second shell. So 4 plus 2 making 6. So this atom contains 6 protons, 6 neutrons, and 6 electrons. You can guess which element this atom represents. It contains 6 protons, 6 neutrons, and 6 electrons. Now, the proton and neutron are located at the center. Protons and neutrons are located at the center. Now, this an atom is electrically neutral. This atom is electrically neutral. And why is this atom electrically neutral? I repeat, this atom is electrically neutral. In other words, it has no charge. It doesn't contain charge. Why? Because the number of protons in the nucleus is equal to the number of electrons within the shells. It has equal protons and electrons. So, why and how does equal number of protons and electrons make this atom to be electrically neutral? You will get the answer as you progress. Now, the protons and the neutrons. As we've already said, and I have already said that the proton contained in the nucleus, neutron contained in the nucleus, and the electron revolve around the shell. Now the protons, now let's look at the subparticles of the atom. The atomic subparticle, in other words, what the atom is made up of, the relative location, position of the particles. Sorry if you cannot see this well, I'm trying to adjust my camera so that now the proton locate particle. In other words, we have proton, neutrons, and the electrons. Relative mass, charge, and location. In other words, location, where can you find that particle in the atom? Where can the particle be found within the atom? The proton has relative mass of 1 and a charge of +1 and is found in the nucleus of the atom. The neutron has relative mass of 1, charge of 0 or neutral, is found in the nucleus. The electron has a negligible mass of 1/1840, very small to point that you can say that the mass of electron is negligible, is acceptable in examination, that you want to identify the particle here and you decide to write negligible as the relative mass of atom here, you'll be marked correct. Now the charge is -1 and the location is the atomic shells, or what we call the orbit. Now this brings us back to the question I earlier asked. Why is it that the atom is electrically neutral? The atom is electrically neutral because in that particular atom we had the number of protons to be equal to 6 and the number of electrons to be equal to 6. Since the proton is positive, so what we have is 6 positive charge plus 6 negative charge. When you sum, plus 6 minus 6 is 0. Plus 6 minus 6 is 0. So as a result of that, the charge of a neutral atom is 0, because the positive and negative charge cancels out and the neutral atom becomes electrically neutral. So when an atom is electrically neutral, know that such atom has equal number of protons and neutrons. If an atom is electrically neutral, know that such atom has an equal number of protons and neutrons. If an atom happens to have a charge, it is positively charged. It means that it has more proton than electron. If it is negatively charged, it means that it has more electron than proton. Let's move to the next slide. Alright, so having said that, the next thing we want to look at, we have defined an atom to be smallest particles of an element which can take part in a chemical reaction and still retain the chemical properties of that element. We equally identify that atom contains 3 subparticles: the protons, the neutrons, and the electrons. That the protons are positively charged particles, neutral charge, electrons negatively charged. The protons and neutrons are found in the nucleus of the atom, while the electron revolve around the atomic orbital. It revolves, or it moves in an orbital path. It is not stationary. It is not stationary. And because of the fact that the number of protons and the electron is usually equal in an atom becomes electrically neutral. So when you see an atom, know that such an atom will have equal number of protons and the neutron in its part. And we'll keep citing example in our calculation that help us to adjust that. So the next thing we want to look at is what we call the atomic number. Atomic number of an element. Now, when we say atomic number, we are simply saying the number of protons that is present in an atom. The number of protons present in an atom. So, atomic number equals to number of protons. And remember that we have said that the number of protons in an atom is usually equal to the number of electrons. But in ion, the reverse is the case. It is not the same in ion. Now, the number of protons, or the atomic number of an element, is usually represented by the letter or symbol Z. Z denotes the atomic number of an element. So that if I decide to use X, this X to denote an element, it means that here Z represents the atomic number of that element, which is Z equals to number of protons. Equals to number of protons. And since it is an atom, it is still equal to number of electrons. But note that while defining atomic number, you don't define atomic number to the number of electrons. Just specifically, specific definition is that it is the number of protons. Because even in an ion, the atomic number is still the same atomic number. The difference between an atom and an ion has to do with the number of electrons that are present. The number of protons is always constant in as much as it is the same atom or the same element that you are dealing with, be it ion or a neutral atom. So the next is mass number. Mass number. So what is mass number? Simply, the mass number is the total number of protons and the neutrons in the nucleus of an atom. The total number of protons and neutrons in the nucleus of an atom. We can refer to it as the nuclear number. The nuclear number or mass number. So if you hear the word nuclear number is used, note that we are referring to the mass number of an element, because it is describing or referring to the particle present in the nucleus of an atom. That's what nuclear number. And in the nucleus of an atom, we have already identified that in the nucleus of an atom, the two particles that are present there is the proton and the neutron. So how? So in an atom, the mass number of an atom is denoted by the letter A. So we use A to denote the mass number of an atom, such that if we have an atom X, we can say that the mass number is A and the atomic number is Z. This represent a typical atom. A equals to neutrons plus protons. YZ equals to protons. This is the particles present in the atom. So with this, we can be able to calculate the number of particles, each of the three subparticles present in an atom. Since we say that the nucleon number minus the proton number will give us the number of neutrons of an atom. In other words, that if we want to know the number of neutrons in an atom, all what we need to do is what? To subtract the atomic number from the mass number. Subtract the atomic number from the mass number, and the remaining will become the number of neutrons. And to find out the number of an electron, what do we need to do? It's just the same as the number of protons. So the number of protons equals to the number of electrons, but the number of neutrons is the mass number minus atomic number. We'll take a class example. So now let's look at just exactly what I discussed about the atom. So looking at this is a typical atom denoted by letter X. This letter S could represent any type of atom. Remember, we have 118 elements in the periodic table. So this X could be atom of calcium, let's say Ca 4020. It could be atom of potassium K 1939. It could be an atom of carbon 12s2 6. It could be an atom of oxygen O 816. So this denotes here the A, as we have identified, equals to mass number. A is the mass number, which is equals to the total number of protons plus neutrons. A is the mass number, which equals to what? The total number of protons plus neutrons. Z is the atomic number, which is equals to number of protons which is equals to what? Number of protons in the nucleus of an atom. Now, you can see here that we cannot use any symbol here to determine the number of electrons. But note that since this species is a neutral species, the number of electrons is equal to also Z, which is the number of protons. The number of electrons become equals to number of so such that in this atom, let's take a case study using the calcium as the case may be. Here, can we identify the number of particles present there? So for we have an atom of Ca40, 20. Can we find out the number of particles present here? Since mass number is equals to 40, atomic number, sorry, let me put number please, NO equals to 40, atomic number equals to 20. It then means that this atom, number of protons in this atom is equals to 20. Number of protons is equals to 20. Now, number of neutrons in this atom is equals to what? 40 minus 20, which will give us equals to what? 20. 40 minus 20, number of neutrons equals to 40 minus 20, which will give us 20. Now, number of what? Electron. Number of electrons, protons, is S equals to proton, equals to what? 20. So that this calcium atom I've seen here contain what? This calcium atom will contain 20 protons, 20 neutrons, and 20 electrons. How did we get the neutrons? For the neutrons, what we did is that we say the mass number, which is A minus Z, equals to neutrons. So our A here is equivalent to this, which is 40. Our Z is equivalent to this, which is equals to 20, giving us 20. Is that okay? So this is how we determine the number of particles present in an atom. Let's move on. So that's the next step of how to calculate the number of protons and neutrons and electrons in an atom. How to calculate the number of protons, neutrons, and electrons in an atom. Let's go through this. We say that the atomic number of an atom and ion determines which element it is. The atomic number of atom or ion determines the type of element it is. It will show you whether the element is carbon, it will show you whether the element is oxygen, it will show you whether the element is lithium, it will show you whether the element is beryllium, hydrogen, uranium, cesium, francium, argon, any chlorine, iodine, any type of element. It is the atomic number that will show you, will help you to identify, because the atomic number is the main identity of that atom. It is the main identity of that atom. All right. The number of protons equals the atomic number. The number of protons of an unknown element can be calculated by using its mass number and number of neutrons. In other words, if you are given an element whose atomic number has not been given to you, but the mass number is given and the number of neutrons is given, you can determine the atomic number. You can determine the atomic number by subtracting the number of neutrons from that mass number. The answer you get happens to be the number of protons. mass number, that's as it explained, equals to number of protons plus number of neutrons. Therefore, number of protons will be equals to what? Mass number minus number of neutrons. Number of protons will be equals to what? Mass number minus number of what? Neutrons. And that will give you the number of the unknown element. Let's go for calculation example. Now let's look at this calculation example. Calculation example. I have two examples here. Number one says we should determine the number of protons, electrons, neutrons in an atom of element S with atomic number 19 and mass number 39. X is an element with atomic number 19 and mass number 39. We are asked to find out the atomic number. We are asked to find out what? The atomic number. Remember that X has been given to us. So let's look at it in this way. So S here is an element with mass number 39 and atomic number 19. So how do we identify the number of protons? Protons number, the electrons number, and the neutron number. This is what we are asked to find out. So here, the protons number is equals to atomic number, which is equals to what? 19. Since X is a neutral atom, the number of proton and number of electron will be the same. Therefore, the number of electron equals to 19. Now, what about the number of neutron? The number of neutron we find out is that mass number minus atomic number. So this will be equals to 39 minus 19, which will give us equals to 20. So therefore, this atom contains the following particles: number of protons equals to 19, number of electrons equals to 19, and number of neutrons equals to 20. This is the number of particles present in this atom. Now, let's assume that this atom happened to be an ion. Let's assume that this atom happened to be an ion and it is carrying charge. Let's assume that this is given to that S is plus this, and that S has mass number. The mass number of S is 39 and its atomic number is 19. It has a charge of +1. So what do we do here? Is it going to be the same answer? No. Which particle is affected by this charge? Let's go on. Here, the atomic number still remains. The number of protons is still the same, which is equals to 19. Now the number of electrons, electron number, is now equals to 90 minus 1, which will be equals to 18. While the number of neutrons is equals to 39 minus 19, which is equals to 20. So you can see now that as this species is now carrying charge of +1, the only particle that has been affected is number of electrons. This means that this atom X has lost ionized by losing one electron. So it has one electron less than the proton. And and that's why it is carrying charge. What again if this S is given to us? What again if this S would have been S, let's say 32, then let me say S 16, then 8. Let's assume this S was this, and it is carrying 2 minus. For when it was plus 2, plus 1, the number of protons is equals to 19. Number of electrons is 19 minus 1 because of this charge here, having 18. Number of neutron is mass number 39 minus atomic number 19, giving us 20. Now I'm giving another S, or let me say this one, let me use Y here, or Y here to denote this particular atom. I want to use Y to denote this atom. This Y having mass number 16, atomic number 8, but it has a charge of minus 2. How do we solve this? Now, because the charge here is minus 2, it means that it has more electron than proton. So let's solve. So here, the number of protons is equals to the atomic number, which is 8. The number of electrons is equals to 8 atomic number plus 2, making 10. Then the number of neutrons is equals to 16 minus 8, which is equals to 8. So, what is the difference between this atom and this atom? This atom gained 2 electrons. It's ionized by the gain of 2 electrons. So it has 2 electrons more than the proton. So there is 10 negative charge and 8 positive charge. So the 8 could not cancel the 10. It cancels out 8 remaining charge of 2 minus. And that's why this atom is electrically carrying a charge of minus 2. But here has more protons than electron by 1. And that's why it is carrying a charge of plus 1. Is that okay? Now let's look at this UTM question. This question is jam question, and with that we'll conclude this first series today. This question, example number 2, I want to write, says, example 2, says we should that the mass number, the atomic number, of cesium atom is 55. And its mass number is 133. That the nucleus of cesium atom, therefore contains, this is Joint Admission and Matriculation Board examination. I don't know the specific here. Now let's look at this question. The atomic number of a cesium atom is 55 and its mass number is 133. the number of cesium atom therefore contain the nucleus of cesium atom therefore contains. Now cesium is element of group 1 the periodic table denoted by the letter CS. Now let's represent it. Now cesium, since the atomic number is 55, we have 55 and the mass number 133. So what does that mean? It simply means that cesium, what we are looking for is the nucleus of cesium. So what is going to be the nucleus of cesium? The nucleus of cesium contain what? What does the nucleus contain? Protons and neutrons, which makes up the mass number. So let's solve first. The number of protons, I just want us to identify every other thing before, but the answer is straightforward. The answer is just this neutron, the nucleus contains 133. But let's see, the number of protons is equal to 55. The number of electrons is equal to 55, since it is a neutron cesium atom. The number of neutrons is equal to 133 minus 55. 133 minus what? 55. So if you minus 55 from 100, you have 45. 45 plus 33 is 78. So which means I'll have what? 78. Therefore, the nucleus, which is equal to the number of protons plus neutrons, will be equal to 55 plus 78, giving us 133. 133. 133. 133. So, and with this, we have been able to identify the nucleus, the content of the nucleus of cesium atom. Before I end the class now, remember that we define an atom as the smallest particles of an element which can take part in a chemical reaction and still retain the chemical property of that element. The atom contains 3 subparticles: proton, neutrons, and electrons. The proton is positively charged with mass of 1 and the charge of +1. The proton is located in the nucleus of an atom. The neutron has a mass of 1, charge of neutral or 0, and located in the nucleus. The electron is negatively charged, has a negligible mass, and is found in the atomic orbital or electron shells. It's found in the electron shells. So, meaning that the proton and the neutrons make up the content of the nucleus of an atom, and the proton and neutrons are referred to as the mass number of an atom. The mass number of an atom, while the proton alone is referred to as the atomic number of an atom. And now in an atom, the number of protons is equal to number of electrons. But in an ion, that is not the case. Depending on the charge the ion is carrying, whether it is a negatively charged ion or a positively charged species. If it is a positively charged species, what it means that it has more proton than electrons. If it is a negatively charged species, it means that it has more electrons than protons. Thank you for watching and listening. You will drop your comment, and when you finish watching, drop your question for answer. Your comment will help us to improve as we start this journey, and I know as we move on, we'll make it better. And don't forget to drop your comment, like and share, so that it can reach as many as possible. This is atomic structure part 1. In our next lesson, we'll be looking at atomic structure part 2. Thank you and have a nice time.